Below is a table showing average heights in centimeters for girls ages 7 through 14. So one of the things I didn't catch when I first read this is it does say that these are average heights. So this to me implies that there's a lot, there could be a lot of sampling that happens to create this 120 for a 7-year-old girl, for example. So it's not just that we made, what, 9 measurements and decided that this is a model. These are average heights in centimeters for girls ages 7 through 15. So because of that, realize there's a lot more data here than it may look like. It says that Leroy calculated the least square regression for this data, and he found it to be y equals 85.5 plus 5.22x. So I want to quickly just confirm that. I've already entered the data using stats edit, but I'm now going to hit stats, go over to calc, and I'm going to go down and perform a linear regression. So I'll hit number 4 and enter that. And when I do that, I get that the y-intercept is indeed about 5.2. I'm sorry, the slope is about 5.22. So for every year increase in age, the height is increasing by about 5.22 centimeters, and the height of a 0-year-old individual would be 84 centimeters. And I think that's kind of, from my experience, I don't remember any of my kids being 84 centimeters long, so that might be a little high for the model. But anyways, we don't go that far down. We're just looking at 7 here. So anyways, this is the model that we have, and he feels it's a good model for his data. And it says use residuals to either confirm Leroy's belief or convince him otherwise. So let's just address that first, right? Is this a good model for the data? Well, one of the tools that we have talked about using in class to decide whether or not a linear model is appropriate for a data set is the shape of the residual plot. So I just created the residual plot. I created all the residuals rather when I ran the linear regression. And if I want to, I can look at the residual plot. So actually, let me just go to second stat plot. And I'm not even going to look at the scatter plot. I'm just going to look at the residual plot. So I'm going to turn this first plot on, and I'm going to get my x values from list 1. And we've been storing the residuals in list 3, but I'm not even going to do that. I'm just going to change list 2 right here to the list of residuals. So those are stored in the list menu. So I hit second list, and I'm going to number 7. So this just grabbed the list of residuals from the most recent regression that was run on this calculator. So when I press, I'm going to press enter, and then I'm just going to ask my calculator to do a zoom and then number 9. And what I'm looking at here are the residuals for this data. In fact, I think I can drag this and put it here, and yeah. So I'll just drop this into OneNote. Whoops. So if you look at it, I can see at first I have negative residuals, and then it goes up to these positive residuals, and then it goes off to negative residuals again. So what I'm thinking is that the model is not the best, right? For people that are age 7, 8, 9, it's predicting a height for them that's lower than it should be, right? It's got these negative residuals. And then for everything above that, it's predicting that it's a little bit higher than it should be. And then it kind of drops off here with the 14, 15-year-olds both being 158. So I would say based on the shape of the residual plot, I would question whether or not a linear model would be appropriate. In fact, I would say a linear model is not appropriate for this data. So that's one thing I'm going to write for my response, that based on the shape of the residual plot, a linear model is not appropriate for this data. The other thing, it says Leroy also thinks he can use the least squared regression line to estimate the height of his 27-year-old cousin Matilda. What do you think? Be clear and complete. So let's just take it on face value. Let's say that we could do that. Well, if she's 27 years old, that would be 85.5 plus 5.22 and then multiply it times 27 years old. So when I do that, I get it's 226.44. Convert 226 centimeters to feet.
226 centimeters is approximately 7.41 feet.
Yeah, so that 7.4, well, I didn't include the 2 but about 7.4 feet. That's it's a very tall person, right? I don't think I don't think I've ever met anyone in my life that is 7 feet tall. Well, and almost 7.5 feet tall. So I think this model is problematic because of that prediction alone. Um, and I think it just is kind of underscores the fact that the model does a very bad job once these numbers get out of this range. Remember, human height is something that definitely we have a growth spurt. We have a time, probably from I don't know what it is for boys and girls. It may be different. But from the age of like 10 through 14, 15, people typically go through a growth spurt, and then it kind of tapers off. We don't keep growing at the same rate throughout our entire lives, our lifespans. Otherwise, it would be huge. Um, so I think that was the other thing. I think this model is flawed for two reasons. It shouldn't be a linear model, but also remember we shouldn't venture too far off to the left or right of our data when we're trying to make predictions. So what I typed was the residual shape, the residual, no, I should say the shape. Okay, I'm proofing it here with you. The shape, the shape of the residual plot indicates that a linear model is not appropriate for the data. We also know that this is true for the situation being described. Human growth is not constant throughout our lifespan. The model predicts that Matilda would be well over 7 feet tall, and an 80-year-old woman would be 16 and a half feet tall. Another model is needed. I will just say that it is important that you did incorporate the use of the residuals in your answer. So that's one of the things that may have caused some point deductions, is that you didn't use the residuals. And I think this was worth 4, maybe 5 points. So there were things that many groups said that I think were very beneficial and true. But again, the heart of this question was, how do we use residuals to decide whether or not a linear model is appropriate for a given situation?